So we're looking at the ticket problem of a system of equations, and looks like the local community theater is selling two types of tickets. We got adults tickets and we got children's tickets, and it's really important to pay attention to what the variables stand for. So we've got adult tickets. We could have called it A or P for parents, but they call it X, and that's fine. But sometimes it's easy to lose it when you're not sure what the letter stands for. So we got X is adult tickets, and we've got Y tickets, children tickets. They tell us what each one costs, that they cost $10 and $5. And they tell us also now that the theater sells out 425 tickets. And that's what this first equation is showing. This first equation says I sold, I'll highlight them in yellow for you, I sold some adult tickets and I sold some child's tickets, and altogether I sold 425 tickets. And that's the structure of the first equation. The second one has to do with how much money they raised. And you can see that they raised $3,250. And they get that by charging $10 for an adult ticket and $5 for a child's ticket. And we're going to go ahead and solve this thing by elimination. And we could eliminate X or we could eliminate Y. If I have my choice, I think I would take the path of least resistance and get rid of Y, because the coefficient on that is only a 5. So I'm just going to have to multiply by a 5. But I also need to be able to make it negative because they're both positive. Everything in here is positive. So I'm going to have to multiply that by a negative 5. So this equation, if I distribute the negative 5, is going to become negative 5x minus 5y equals, I'm going to do some quick math in my head, that is going to be negative 2,125. Let's hope I didn't make a mistake there. And I'm going to copy the bottom one down. So that's 10x plus 5y, and there we go. We're going to get rid of the y's. Those are going to turn to zeros. And that's positive 3,250. So that was 0. There's no more y's, but that's only 5x. And now I've got to come over here and do some subtraction, 3,250, because I'm not going to be able to do that in my head on a Wednesday afternoon. So let's just do some quick subtraction here. That's a 5, that's a 2, that's a 1, 1. So we got 1,125. And we're going to divide that by 5 because that's gone. And 5 into 1,125, that's 2, that's 10, and it goes into 12 twice, and I got 25. So 225 is X, and that was adult tickets. So X is 225, and I know that if I look at this top equation, well, if I sold 225 of X, I have to get 200 Y in order to add up to 425 tickets. So that's going to be our answer. We got 225 adults, and we got 200 kids tickets in order to make it work. So let's take a look at this equation. We'll go from start to finish. We're going to sell some adult tickets again and some kids tickets, and this time they're going to let me choose variables. So I'm going to let A equal adult, and I'm going to let K equal kids, and that way when I solve for one variable or the other, I'll know exactly what it means. Adult tickets are $5.50 and kids are $4. So that means that I'm going to have $5.50 times A and $4 times K, right? A kid's ticket's only $4, so it's going to be $4. And since I have all the decimals on the adult, I'm going to keep the decimals on the kids. And it said they sold a total of $245 worth of tickets. So there's our first equation. This was money, and the total was money. And if I want to do that, I can have the decimals there too. And somewhere in here it says 50 tickets were sold. That means I sold some adults and some kids, and I sold 50 total. That means A plus K. And just to line up the K's with the top equation, I'm going to do that, and that was 50. So I'm going to probably take off these decimals. I don't think I'm going to need those at this time. Maybe I will. Who knows? I notice that I have a 4 here, so I'm going to turn this into a negative 4. And the way I'm going to do that is I'm going to multiply the whole bottom equation by a negative 4. That's going to give me a negative 4k, and that's going to make this k go away. So let's distribute the negative 4. We got negative 4a, negative 4k, and a negative 200. And the top equation was 5.50a plus, I'm going to take off those decimals now on the plus 4k. I'm going to pretend I didn't do that because I don't need them, equals 245. And I'm going to add these up because those k terms are going to disappear. Right? Those are going to turn to zeros. And 5.5 a's take away 4 is 1.50 if you wish. You don't really need that. And that was a 245, so that's going to equal a 45. We're going to divide this by 1.5. You can divide it by 1.50. You drag your calculators out if you want. I know that 15 goes into 45 3 times, so 1.5 goes into 45. 30 times, that means I sold 30 adult tickets. If I sold 50 altogether, that means I have 20 kids tickets to solve my system. So I sold 30 adult tickets, 20 kids tickets. All right, here we go with a coin problem. Seems like every systems of equation problems has these, and this one, oh, that would have been nice if I was highlighting, Ron has 19 coins, and I know that he also has, some of those are nickels, and some of those are dimes, and we're going to call nickels N, and we're going to call dimes D. And it says I have 19 of them, and I have some nickels and I have some dimes, and that means that I have an equation that says N plus D equals 19. And that just represents how many I have, and there's a value here too. Nickels are worth 5 each. And I could use 0.05, but I'm not going to because I don't like decimals. And we're going to call dimes, they're worth 10D, and his total is $1.40. But because I didn't write these with decimals, I'm going to have to call that 140. So nickels are worth 5 each. That's 5N plus 10D equals 140. Again, if I want to move the decimals back twice, I could, and that could be 0.10 and this could be 0.05, but it's really not helpful to have all the decimals. I'm not a big fan. So we're going to get rid of, if you are deciding now, would you rather turn a 1 into a negative 10 so you could get rid of the D, or would you rather turn this 1 into a negative 5 so you could get rid of 5N? I know what I would rather do. I'm going to multiply by 5, but I notice that everything in there is positive, and I need an opposite sign. This right here is positive 5N, and I need this to be a negative. So I'm going to multiply this, and I'm just going to write it right down here underneath. So negative 5 times N is negative 5N, and now you can see that they're going to cancel out, turn to 0. And then that is a negative 5 times 1 is negative 5D. Please don't put plus, a minus. And then this over here is a negative, and that's 95. So if I take a look here, the N's are going to go away. That's a 0. That's plus 5D equals, and 95 taken away from 140 is 45. So when I divide this by 5, I get the number of dimes already. D is 9. So he has 9 dimes. And it told me I have 19 altogether. Well, 9 of them are dimes. That means 10 of them had to be nickels because 10 plus 9 is 19. So there you go. There's one example of the coin problem, and there's nickels and dimes. And you can understand now, or you can see why the value or the help in using appropriate letters to make sense of our solution. Here we have 9 coins, so the number is a little bit smaller. But I have nickels and I have quarters, so we're going to have N and we're going to have Q. And when it comes time for the value, it's going to be 5N and then 25Q. So I have 9 coins. Let's deal with that equation first. The number of nickels plus the number of quarters equals 9. And there's only so many ways you can come up with combinations of 9 coins. So you might even be able to guess and check this problem pretty quick. But we'll do it with algebra because, hey, math. 5N plus 25Q equals I'm going to, again, I lost the decimal, so I'm not going to write these with decimals. That's 145. And just like the last time, it's easier to multiply by a -5 than it would be a -25. I wouldn't do that. So let's multiply this by a -5, and that's going to turn, we're going to multiply that -5 times all three terms. So on the right side is going to be a -45. Here's a -5q, and that's a -5n. And you can see that those are going to turn to zeros, and that's going to be 20q equals 100, and when I divide by 20, q is 5. So we have 5 quarters. You only had 9 coins, so 4 of those were dimes. It's not a terribly difficult problem to do. You could guess and check it probably in about the same amount of time.